The National Electrical Code, Section 406.8b addresses receptacles in bathrooms. It states that in bathrooms, at least one receptacle outlet shall be installed within 3 feet of the outside edge of the sink. Section 406.9a uncovers ground fault circuit interrupter protection. It specifies that all receptacles installed in bathrooms shall have ground fault circuit interrupter protection. The commentary on Section 406.8b explains that this requirement is intended to provide convenience and accessibility to a receptacle near the sink for hairdryers and other appliances. The commentary on Section 406.9a clarifies that ground fault circuit interrupter protection is required in bathrooms due to the increased risk of electrical shock from moisture and water. While the code does not specifically address the placement of ground fault circuit interrupter receptacles directly above sinks, the intent of the code is to provide convenient access to a receptacle near the sink while also ensuring protection from electrical shock. The placement of the ground fault circuit interrupter receptacle directly above the sink may not be optimal from a convenience standpoint and could potentially get in the way of using the sink or be difficult to reach. However, if it is within 3 feet of the sink, it does meet the code requirements for ground fault circuit interrupter protection and is not necessarily a violation. While not a code violation, it may be advisable to move the ground fault circuit interrupter receptacle to a more convenient location, such as to the side of the sink or on an adjacent wall. This would improve accessibility and functionality without compromising safety. Ground fault circuit interrupters, or GFCIs, are crucial safety devices designed to protect individuals from electrical shock. They work by constantly monitoring the current flowing through a circuit. If a difference is detected between the outgoing and returning current, even a tiny difference as small as 5 mA, the GFCI will quickly trip, cutting off the power to the circuit. This rapid response helps prevent potentially fatal electrical shocks. The reason bathrooms, kitchens, and other areas near water sources require GFCI protection is due to the increased risk of electrical shock when water is present. Water is a good conductor of electricity, and even small amounts of moisture can create a path for electrical current to flow through a person's body, leading to serious injury or death. By installing GFCIs in these areas, the risk of electrical shock is significantly reduced. In addition to bathrooms, the National Electrical Code mandates GFCI protection in other locations where water is commonly present, such as kitchens, garages, unfinished basements, and outdoor areas. The specific requirements may vary depending on the edition of the code and local regulations, but the general principle remains the same: ensure that GFCIs are installed in areas where there is a heightened risk of electrical shock. When selecting a GFCI receptacle, it is important to choose one that is listed by a recognized testing laboratory, such as Underwriters Laboratories or UL. This listing indicates that the device has been tested and meets established safety standards. It is also important to ensure that the GFCI receptacle is properly installed by a qualified electrician. Incorrect installation can render the device ineffective, negating its safety benefits. Regular testing of GFCI receptacles is also essential to ensure that they are functioning correctly. Most GFCI receptacles have a test button that can be used to simulate a ground fault. Pressing this button should cause the GFCI to trip, indicating that it is working properly. It is recommended to test GFCI receptacles at least once a month to verify their functionality. If a GFCI fails to trip when tested, it should be replaced immediately. In summary, ground fault circuit interrupters are vital safety devices that protect against electrical shock. Their installation is mandated by the National Electrical Code in areas where water is commonly present, such as bathrooms, kitchens, and outdoor locations. Proper installation and regular testing are essential to ensure that GFCIs are functioning correctly and providing the intended level of protection. When planning electrical work in a bathroom or any other area requiring GFCI protection, it is always best to consult with a qualified electrician to ensure that the installation meets all applicable code requirements and safety standards. An electrician can assess the specific needs of the project and recommend the appropriate GFCI devices and installation techniques. Furthermore, electricians are trained to identify potential hazards and ensure that the electrical system is safe and reliable. The NEC provides specific guidelines for the placement of receptacles in bathrooms, taking into account factors such as convenience, accessibility, and safety. The requirement for a receptacle within 3 feet of the sink is intended to provide a convenient power source for small appliances such as hairdryers and electric razors. However, the code also recognizes the importance of minimizing the risk of electrical shock in these areas, which is why GFCI protection is mandatory. While the NEC does not explicitly prohibit the placement of a receptacle directly above a sink, it is generally recommended to avoid this location if possible. The rationale is that placing a receptacle directly above a water source increases the likelihood of water splashing onto the receptacle, which could create a shock hazard. Additionally, a receptacle directly above a sink may be less convenient to use, as it may be difficult to plug in and unplug appliances without getting water on them. In situations where it is not practical to avoid placing a receptacle above a sink, it is essential to take extra precautions to minimize the risk of water exposure. This may include using a receptacle cover that is designed to protect against water splashes, or installing a small shelf above the sink to provide a barrier between the water and the receptacle. It is also important to ensure that the receptacle is properly grounded, as this will help to prevent electrical shock in the event of a ground fault. In addition to the placement of receptacles, the NEC also addresses the wiring methods that are permitted in bathrooms. In general, the code requires that all wiring in bathrooms be installed in accordance with the requirements for wet locations. This means that the wiring must be protected from moisture and corrosion, and that all connections must be watertight. The NEC also specifies the types of wiring that are permitted in bathrooms. In general, non-metallic sheathed cable, or NM cable, is permitted in dry locations, while metallic conduit is required in wet locations. However, there are some exceptions to these rules, so it is important to consult the NEC for specific requirements. When performing electrical work in a bathroom, it is essential to follow all applicable code requirements and safety standards. This will help to ensure that the electrical system is safe and reliable, and that the risk of electrical shock is minimized. It is always best to consult with a qualified electrician before undertaking any electrical work in a bathroom, as they can provide expert advice and guidance. The NEC is updated on a regular basis to reflect changes in technology and best practices. It is important to stay up to date on the latest code requirements to ensure that electrical installations are safe and compliant. The NEC is available for purchase from the National Fire Protection Association, or NFPA, and can also be accessed online through various subscription services. In addition to the NEC, many states and local jurisdictions have their own electrical codes that may be more stringent than the NEC. It is important to check with the local authorities to determine the specific requirements that apply in your area. Electrical safety is a serious matter, and it is essential to take all necessary precautions to protect yourself and others from electrical hazards. Always follow safe work practices when performing electrical work, and never attempt to work on live electrical circuits. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. The electrical code is not intended to be a design guide, it is primarily for safety. The code sets the minimum standards for electrical installations. It is up to the designer or installer to determine the best way to achieve the desired functionality while meeting the code requirement. While the NEC mandates GFCI protection for bathroom receptacles, it does not dictate the specific type of receptacle that must be used. There are several different types of GFCI receptacles available, each with its own advantages and disadvantages. One common type of GFCI receptacle is the combination GFCI receptacle, which combines the functions of a standard receptacle and a GFCI device in a single unit. These receptacles are easy to install and are a good choice for replacing existing receptacles. Another type of GFCI receptacle is the GFCI circuit breaker, which provides GFCI protection for an entire circuit. These breakers are installed in the electrical panel and are a good choice for new installations or for protecting multiple receptacles in a bathroom. In addition to GFCI receptacles, there are also GFCI portable devices available. These devices plug into a standard receptacle and provide GFCI protection for any appliances that are plugged into them. Portable GFCI devices are a good choice for temporary installations or for protecting appliances that are used in multiple locations. No matter which type of GFCI device is used, it is important to ensure that it is properly installed and tested. GFCI devices should be tested regularly to ensure that they are functioning correctly. If a GFCI device fails to trip when tested, it should be replaced immediately. Electrical work should be performed by a qualified electrician. First, ensure the power is off. Second, test the circuit to ensure it is energized before working on it. Third, follow the manufacturer's instructions when installing electrical equipment. Fourth, never overload electrical circuits. Fifth, use ground fault circuit interrupters in areas where water is present. The location in the bathroom has other codes related to it. Firstly, lighting must meet minimum illumination requirements for safety and usability. Secondly, ventilation is necessary to remove moisture and prevent mold growth. Thirdly, clearances around electrical panels must be maintained for safe access and maintenance. Fourth, smoke detectors may be required in or near the bathroom depending on local regulations. Finally, adherence to the Americans with Disabilities Act, also known as ADA, guidelines may be necessary in some cases to ensure accessibility for individuals with disabilities. Local codes and ordinances should be followed, and the authority having jurisdiction is typically responsible for interpreting and enforcing these codes. The authority having jurisdiction may be a building inspector, electrical inspector, or other official. The role of the authority having jurisdiction is to ensure that electrical installations are safe and comply with all applicable codes and regulations. The authority having jurisdiction has the power to approve or disapprove electrical installations and to require corrections to be made if necessary. It is important to work with the authority having jurisdiction to ensure that your electrical installation meets all applicable requirements. The NEC is a comprehensive document that covers a wide range of electrical topics. It is important to consult the NEC for specific requirements related to your project. The NEC is updated every 3 years, so it is important to use the latest edition of the code. The NEC is available for purchase from the National Fire Protection Association. Many states and local jurisdictions have their own electrical codes that are based on the NEC. It is important to check with your local authorities to determine which codes apply in your area. If you are not familiar with the electrical codes, it is best to hire a qualified electrician to perform the work. A qualified electrician will be familiar with all applicable codes and regulations, and will be able to ensure that your electrical installation is safe and compliant.